Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, we're here to unravel the complexities of decentralized systems. Before we dive in, if you're enjoying our content, please take a moment to rate us on your podcast platform. Your support means the world to us. Today we're continuing our journey through Chapter 5, Networking in P2P Systems, and we'll be exploring the Gnutella protocol. To kick things off, I have a quiz question for our listeners. Victor, would you like to hear it?
Absolutely, Sheila. I'm always up for a good quiz. Let's hear what you've got for our listeners today.
All right. Here's the question. In what year was the Gnutella protocol first released, and how long did it take for the network to grow from 0 to an estimated 10,000 users?
Oh, that's an intriguing question, Sheila. It touches on both the historical aspect and the rapid growth potential of P2P networks. I think our listeners might be surprised by the answer, especially considering how quickly technology can spread in the digital age. Without giving away too much, I'd say this question really highlights the power of decentralized systems to scale rapidly without central coordination.
You're right, Victor. It's a fascinating piece of P2P history. Now, before we delve deeper into Gnutella, could you give us a quick refresher on what we mean by a P2P protocol in this context?
Certainly. A P2P, peer-to-peer protocol, is a set of rules that governs how computers in a decentralized network communicate and share resources directly with each other without the need for a central server. In the case of Gnutella, it's specifically designed for file sharing across a distributed network.
Thanks for that clarification. So let's start with the basics of Gnutella. What exactly is it, and how does it differ from other P2P protocols we've discussed, like BitTorrent?
Great question. Gnutella is one of the first truly decentralized P2P file-sharing protocols. Unlike BitTorrent, which uses a hybrid model with trackers, Gnutella operates on a pure P2P network where every node can act as both client and server. It uses a method called query flooding to search for files across the network.
Query flooding. That sounds interesting but potentially problematic. Can you explain how that works and why it might be an issue?
Absolutely. In query flooding, when a user searches for a file, their query is sent to all neighboring nodes, which then forward it to their neighbors, and so on. This can quickly spread the query across the entire network, but you're right to point out that it can be problematic. It can lead to network congestion, especially as the network grows larger.
I see. So how did Gnutella address this scalability issue?
Great question. Gnutella evolved to use what's called an ultrapeer, leaf node architecture. Ultrapeers are nodes with high bandwidth and availability that act as mini-hubs connecting to many leaf nodes. Leaf nodes are regular users who connect to a small number of ultrapeers. This hierarchy helps reduce network traffic and improve efficiency.
That's fascinating. It's like they created a sort of organic structure within the decentralized network. Can you draw an analogy to help our listeners visualize this?
Certainly. Think of it like a tree structure. The ultrapeers are like the main branches, strong and well connected, while the leaf nodes are like the leaves themselves, numerous but each only connected to a few branches. This allows information to flow efficiently through the network without overwhelming it.
That's a helpful analogy. Thanks. Now, you mentioned earlier that Gnutella was one of the first truly decentralized P2P protocols. Can you tell us a bit about its history and why it was significant?
Of course. Gnutella was initially created by Justin Frankel and Tom Pepper of Nullsoft in 2000. Its significance lies in the fact that it was one of the first P2P networks that could continue functioning without any central servers. This made it incredibly resilient. There was no single point of failure that could shut down the entire network.
That's really interesting. I imagine that resilience made it quite popular. Were there any challenges or controversies surrounding Gnutella?
Absolutely. Like many file-sharing networks, Gnutella faced legal challenges due to copyright infringement concerns. Additionally, its open nature made it vulnerable to pollution attacks, where fake or corrupt files were introduced into the network. These issues, combined with the scalability challenges we discussed earlier, eventually led to a decline in Gnutella's popularity as more efficient protocols emerged.
I see. It sounds like Gnutella played a crucial role in the evolution of P2P technology, even if it's not as widely used today. Are there any lessons or technologies from Gnutella that are still relevant in modern P2P systems?
Excellent question. While Gnutella itself isn't widely used anymore, many of its concepts have influenced modern P2P systems. The idea of a decentralized search mechanism, the ultrapeer architecture, and the focus on resilience are all concepts that have been refined and incorporated into newer protocols. Additionally, Gnutella's challenges helped the P2P community better understand the trade-offs between decentralization, efficiency, and scalability.
That's really insightful, Victor. It's fascinating to see how these early protocols laid the groundwork for the systems we use today. Now, before we wrap up, let's return to our quiz question. Can you reveal the answer?
Certainly. The Gnutella protocol was first released in March 2000. And believe it or not, it only took one day for the network to grow from 0 to an estimated 10,000 users. This rapid growth demonstrates the viral nature of P2P networks and the huge demand for decentralized file sharing at the time.
Wow, that's incredible. From 0 to 10,000 users in just one day. It really shows the power of decentralized systems to scale rapidly. To summarize today's episode, we've learned about the Gnutella protocol, one of the first truly decentralized P2P networks. We discussed its query flooding mechanism, the ultrapeer leaf node architecture it developed to address scalability issues, and its historical significance in the evolution of P2P technology. While Gnutella itself isn't widely used today, its legacy continues to influence modern decentralized systems.
That's a great summary, Sheila. I hope our listeners have gained a deeper understanding of Gnutella and its place in the history of P2P networking.
Thank you, Victor. And thank you to all our listeners for tuning in. If you've enjoyed today's episode, please visit crashcasts.com to learn more about decentralized application development. You can also join our Discord community to discuss these topics further, or support us on Patreon if you'd like to help us keep producing this content. Don't forget to subscribe and rate our podcast. It really helps us reach more people interested in decentralized technologies. Until next time, keep exploring the world of P2P.